I'd like to start off by saying that both Shankar Ghosh, who's working with me on this and is sort of the main person, Shankar and I are both physicists. We have no idea of viruses. We're not biologists. We are not clinicians. We are physicists, and we are trying to play around with masks and filtration. That's basically what we are trying to do. And today, I would like to essentially look at two things. One is, if you are going to run out of these N95 masks, is there a way to decontaminate and reuse them? And related to this is, if you zap the virus in any way you like, you decontaminate it, how do you know that the mask is still good? And given that currently it's probably impossible to get professional equipment to test masks, we sort of decided to play around and came up with a very, very simple sort of homemade thing done during the lockdown. And using this setup, we have some rather interesting and perhaps relevant observations for people using these masks in the field. So that's hopefully what I'll tell you in about the next 10-12 minutes. And just to start off with, I just want to make sure that we understand the difference between these surgical masks and what are called the N95 respirators. Now, the surgical mask, this is from the CDC page, essentially protects you against large droplets coming in, and it's mainly meant to protect people other than you from whatever you may be spitting out or while you're talking, large droplets. Whereas these masks, the N95s, are supposed to protect you against very small particles, 0.3 micron particles, 95% of them. And for this, one of the most important things is fit. So these masks, now these can be cloth masks, these can be these sort of what are called disposable masks, which are made of some polymer material. These don't fit very tightly. There's a lot of gap at the sides. Compared to that, the N95s, whether it is these molded ones, so there are two types, it could be molded in this shape, or there are the ones that are flat. In any case, these are meant to fit very snugly against your face, and the fit is more important. Most of the leakage through these masks is not actually due to the poor material, but due to the poor fit. So fit is one thing which is very important, especially if you want to reuse a mask. So typically these masks were always designed, the manufacturers designed them to be used only once, single use. But given the current situation due to this pandemic, people are trying their best to figure out how we can reuse them because of a shortage. Now, clearly, there are various things one can worry about. For example, most people are just doing what is called decontamination, which means a 99.9% reduction in the number of active virus particles on it. It's not really sterilization, which is a lot more strict in its thing. Now, one important thing is, no matter what way you use to remove the virus or inactivate the virus, it should not impact the efficiency of filtration and also how well it fits on your face. And this can often be not just the material going bad, but as simple as things like, if you steam a mask, the straps may come off, right? Or the rim of the mask, or the molded masks, the rim can get deformed. So this is sometimes the main limitation. And in any case, if you take a mask on and off 5 times, that itself will sort of deform it a little bit and reduce its fit. Now, in the last month, there have been a lot and lots of reports on bioRxiv, medRxiv, etc., on mask reuse, and many of these things have often inconclusive or maybe even contradictory things. So I think if you're using this, before you actually decide to just follow a recipe and do it, please check yourself with some masks before you use it. A lot of what I have in the next couple of slides are actually from a site called n95decon.org. This is an international consortium of mainly volunteers who have been looking at and summarizing different studies and reports and protocols for how one can decontaminate masks. So the first thing is, let us see what doesn't work, because I think that's very important to know what doesn't work. While alcohol is very good for hand disinfection and sterilium is everywhere around, alcohol and alcohol-based materials are deadly for these masks. Now, the reason the N95 mask is very efficient in filtering is because it has an internal layer which has electrostatic charge, and the alcohol actually removes the charge from this layer. Similarly, soap water and detergents are not good. Bleach, hypochlorite solution, The problem is there are two things. The efficiency could get degraded, but more importantly, even a small residue of it is not going to be very good for the person use it next time. Similarly, ethylene oxide, standard for sterilization, but even tiny residues, it's a toxic gas, so it's not a good idea. Gamma ray radiation, a couple of groups have shown that it cannot be used because the gamma rays damage these polypropylene fibers in the mask and again remove the charge, so the efficiency goes down. And though sunlight contains a small UV component, this is in what is called the UVA region, like tanning lamps, this does not deactivate the SARS-CoV-2 virus. Okay, so what works then? So that's what one shouldn't use. There are a couple of methods which have been shown to work. A lot of the large-scale industrial process is with something called hydrogen peroxide vapor. This probably it's something called the Battelle process, which has been now licensed for free to many hospitals in the US, but this is probably a little cumbersome. The three methods which I think are sort of relevant for, especially for the Indian context, are simply time. You take a mask, keep it out for a while carefully, and then use it after a given amount of time. The other one for a quicker turnaround is heat, especially moist heat where you can control the humidity. And finally, there is ultraviolet light. Ultraviolet light UVC can be used to decontaminate masks. People have tried other things like dry heat and autoclaving and liquid hydrogen peroxide, but we're not really, it's not very clear what is the best way to do it. So let's just look at these three things which might work for us: time, heat, and UV. I'll start with UV because this is probably the most sort of technically challenging one. Now, you need enough dose of UV radiation on the mask surface, which is much more than the typical UV used for air purification. You need what is 1 joule per centimeter if you want to get numbers into it. And this is not, if you have a bio hood which has these UV lamps, you might have to keep it there for way too long before you can get to this 1 joule level. The good thing though is these UV lamps at 254 nanometers should be available widely everywhere because these are the lamps which are used in all the AquaGuard and other water purifiers. Now, the problems with UV are the following. UV light doesn't penetrate very much into the material, so it's mainly a surface thing. And the biggest problem is shadows. Now, these masks have curved shapes, so unless you're careful of where your light source is, you will have shadows. The straps will cast a shadow. So to get uniform illumination is a challenge. Also, one has to be sure to measure the intensity of the surface. You cannot just go by what the lamp lamp is 11 watts and hence I should expect so much. It's always necessary to measure the thing. Poor quality lamps, often the ones which have stray emission at less than 200 nanometers, will generate ozone. This is not good for if you're breathing it. Similarly, UV could be dangerous for the eye and you'll have to protect this enclosure very much. And you cannot do this for more than a few cycles because UV anyway damages plastics. Okay, but there are open source designs for UV cabinets that have been published. If you want to do this method, it is possible. In a hospital setting, perhaps the easiest one to consider is heat. Now, the issue with heat is the inactivation of the SARS-CoV-2 virus is very, very sensitive to the temperature and humidity and the surface. And various studies, very few of them are actually on N95 masks. They are on, either cloth or steel or, paper, cardboard. And it's comparing these numbers is really difficult. And you cannot make it too hot because you will either melt the plastics or melt the straps, or, these straps tend to be welded. They're just spot welded here. They come off. So you cannot really get the temperature too high. Now, somehow dry heat does not seem to be as effective. Even 70 degrees centigrade, half an hour does not inactivate the SARS-CoV-2 virus. You need more than an hour. However, adding a little bit of humidity seems to get this process done much quicker. Now, remember that there are very few studies on exactly the SARS-CoV-2 virus. Most of these are on other surrogate viruses of a similar type. But people have also tried the standard autoclave method because most hospitals have it. Autoclaves are okay for these fold flat masks like this, but they are actually not at all good for the molded masks of this sort. Okay, so the recommendation from heat is typically 70 to 80 degrees centigrade, 50% humidity, and it seems to vary very strongly with the exact mask. So you have to check on whichever mask you are using, and you have to be very careful about the control of temperature and time. So the easiest thing perhaps is to just keep the mask out for a while, just time. Any virus on a surface will eventually start degrading, and after some time, the number should reduce. Now, here is where is probably the most confusing evidence so far that has been there. Now, the CDC guidelines actually say that 96 hours is sufficient to sort of reduce the virus load to 3 log, 99.9%, and they recommend a 5-day gap between using your mask. So if you have enough masks, you use mask 1 today, keep it in a well-aired paper bag or something, and come back to it on day 6. That should be good enough. However, there have been a few recent studies. Now, remember, these are all on medRxiv or things. These are not sort of peer-reviewed studies as yet. There are studies on room temperature. Now, this is room temperature in a colder place where it's 22 degrees, said that you should wait for a week, 168 hours. And it's really, really crazy because it seems to be very strongly dependent. For example, temperature. I mean, of course, Indian conditions should be hotter, so it should take less time. But even this N95 decon group from where I have taken it actually says that the literature has a huge number of gaps. In fact, the thing is, from the same data, different groups are extrapolating different times, and this is a hugely uncertain process. So I would think in Indian conditions, 5 days between usage seems to be logically consistent, but I think this is an area where the studies are still not very conclusive, especially for SARS-CoV-2, because there are not too many studies. The important things to remember for this is, unlike some of these other processes, we can take masks in a batch, put them all together, and return any mask. It's best that you use your own mask on the 5th or the 6th day. It's only for one user. You should not trade the mask between other people. And while keeping it outside will decontaminate, remove the virus, it may not remove bacteria and prevent mold growth. So that is something that one needs to inspect the mask and check always. And the mask needs to be kept in a well-aired place, not in a sealed plastic bag, for example. Okay, so those were sort of the summary of the do's and don'ts for decontamination. What I'm going to move to from here is, whatever you do, you want to check, does your mask filter as well as it does? And what we did was we came up with using air pollution monitors, which are particle counters, as a very simple method of trying to check what is the filtration efficiency on the mask. And this is actually the system behind me over here, this pink little thing which you see over here. We don't have a proper phantom of a face and everything. We have a ball on which we put a mask. We suck air through it. We count the number of particles coming through the mask versus the number of particles in air. And from this ratio, we can find out the efficiency. And we can build a reasonable bare bones setup for as low as 20,000 rupees and not 20 lakhs. Now, this itself is a very sensitive thing that has taught us a lot about how masks behave. And I'll just show you a few things. So while we may not be able to measure absolute numbers with X% efficiency plus minus 0.1%, we cannot do that. What we can definitely do is look at relative changes. And as I said, fit is very important. So if you just attach a mask, what you see on the left, if you attach a mask and it is just, this is a mask which had rather loose straps. If you just attach a mask with straps to, like ears, imagine we have 2 nails on which we strapped it. Even though it's an N95 mask, there's only 71% filtration because a lot of air is leaking through the sides. Now, what we do is we take some paper tape and put it around the side, and there you go. You can see the filtration efficiency has gone down. The particle count has gone down. You are more than 95% efficient. Of course, this is a plastic ball, not a human face, so we should be careful. And here again, you can see that different masks behave differently. Some masks, like on the left, are very leaky. Other masks hardly require any taping. They actually fit very well. There's a sharp drop, and okay, a little bit of change. Of course, when you tape it, you can get down to about 95% level. So every mask is different, and it's good to check. The other thing is, some masks can be pretty, you can one of the problems, especially with masks which have these exhaust valves, these are actually not recommended for medical use at all, I think. This exhaust valve provides a zero resistance path to air going outside, right? And this has a little rubber gasket that seals. And if you try to expose this mask to sort of hot air or hot steam or hot moist air, this rubber gasket is easily deformed. Again, don't worry so much about the absolute numbers. What you see in a new mask, there is hardly any difference, whether the valve is open or if we have to sometimes put tape on it. Whereas with a used mask, which has been decontaminated by heat, you can see that there is a lot of leakage through this valve, and you have to actually tape the valve shut before you can get down to these 90% filtration levels. Again, this is just to illustrate relative changes. People ask, what about surgical masks? Well, we have made these measurements. A typical one of these green cloth masks that you find in every hospital, these will filter at about 50-55% levels. Of course, what you can do is you can add another mask to it. You can put two masks in series, and you can easily get down to about 85-90% levels in an emergency. It's just the additive property of going through two masks, but obviously this is also going to make breathability more difficult because you have more layers in front of you. A simpler solution might be to ensure fit using a tight rubber gasket. Okay, so you can take and this is from a site called fixthemask.com. What they have done is they have given a design for people to cut out a piece of rubber in this shape. And this rubber gasket, what it does is you can take a surgical mask or any mask which is not fitting very well, because fit is the most important thing. You put the mask and then use this gasket. This gasket, it sort of fits over the nose, fits over the below the chin, and you tape it, pull it over your head, and this gives you a very tight fit. And what we find with this is if you have a very good surgical mask, for example, some of the very good 4-ply surgical masks, you can easily get down to 90+% efficiency even using a good surgical mask. But for any mask, this is actually a very good way to use a tightening sort of a gasket or a tight rubber band. They've given some designs on their site where you can use thick rubber bands to do the same thing if you cannot cut a gasket in a rubber sheet in this shape. We have used sheets from this is rubber sheet. We've also cut the gloves, these acid gloves that you find, thick gloves. They also work reasonably well. So I'm going to stop here, and my take-home message is basically the following. Not all commercially available masks are the same quality. Even if they filter at 95% level, there is a big difference between build quality. And this is very important if you plan to reuse the mask. If the strap is flimsy, you may not be able to reuse it at all. Okay, but these masks can be decontaminated with heat by just keeping it out for 5-6 days, or by UV. There are ways you can do it relatively easily. And in an emergency, cloth masks and surgical masks are not too bad. And sometimes it's better to have 70% protection that is 70% than a badly fitting N95 where you don't know what it is. And if you have 4-ply surgical masks with a nice gasket, you could get as close to 90% protection. So these simple methods of having a tight fit is key to being able to get good filtration efficiency. And one thing I must say is, I think the healthcare providers must be told to take extreme care while taking off a mask. It seems that most of the infections in hospitals have come because people have been a little careless and have touched the outside surface of the mask, which is contaminated, and then transferred this either to their shoes or something else. And this is where donning and doffing procedures have to be very well defined in these settings. So yeah, that's all from me. I'm going to stop sharing my screen, and I'll be happy to take questions that may be there.
Thank you very much, Arnab. That was very informative, and it did come as a surprise to us that while we obsess about the filtration capabilities of these masks, we don't pay as much attention to the fit, which, as you clearly demonstrated, seems to be as important, if not more important than the filtration capacity. So I'm going to put through a few rapid fire questions to you, because these are probably yes or no answers that you could probably look at. So how good is formalin fumes to decontaminate N95s?
I haven't seen any report of that, so I really don't know. I can check and get back to you, but I haven't really seen that as a decontamination method for masks.
Right. So there's a couple of other similar questions. What about ozone gas?
People are trying ozone. The N95 Decon group they are going to be coming out with SOP for using ozone, hopefully in a couple of days, is what they say.
What about plasma sterilization?
Plasma sterilization, at least what we found when we did some initial experiments with plasma, they can remove these charges on the mask. So you might lose efficiency, is my gut feeling. Plasma it's ionized. I mean, there's electrical charges, so they'll remove whatever charges on your mask, and having the charge is very important.
Right. So you mentioned that moist heat was efficient. So can we use autoclaving as a method?
So yes, I mean, autoclaving 121 degrees centigrade, 15 minutes has been used for these flat masks, the ones which fold flat, not for the molded masks, which are like this. These get deformed at high temperatures. You might be able to get away with these masks, but again, you are reaching sort of the limit for plastics where they will start melting. So you have to be careful. the recommended temperature is actually 75 to 80 degrees is where is the sweet spot for this. But people have autoclave. There is something on autoclaving masks for the flat mask. Yes.
Right. A number of questions on what are simple things that we can do at home to decontaminate masks. I guess a lot of healthcare workers who are at home, what method would be easy to use?
So one advantage of moist heat is that you can pretty much do this over a water bath everywhere, anywhere. So I mean, people in the sort of there are many groups, especially in Africa, other places, India, who are just using pressure cookers, hot water boiling, holding it above boiling water. If you have a microwave and there are no microwave will not is dangerous if you have metal straps like this. If you have the metal nose clip, you'll spark from there. But if you don't have metal, you can put a bowl of water in the microwave and use microwave generated steam. People have tried that. So I think if you're at home and it's your own mask, if it's a cloth mask which is not dependent on charges, just wash it in regular laundry. That's good enough. But if it's a N95 mask where you want to preserve the charge, you can do the same 75-80 degree moist heat by holding it above hot water effectively. But right. The problem is it's difficult to check. It's very difficult to confirm, have I done it enough or not? So it's probably good to overdo it rather than underdo it. If somebody says, so some of these things have where they say half an hour is enough, maybe it's good to do it for a little bit more time.
Right. So
and both surfaces.
Right. So and there are some questions which go out of your area of direct work, but based on your association with Decon 95, how long can an N95 be used at a stretch, and before you need to keep it away for airing?
Okay, I don't have the data or the expertise to answer that, and I don't think the N95 has looked the Decon community has looked at it because they were looking primarily at decontamination. But clearly, humidity is going to affect the efficiency of your mask. If you're going to be breathing in and out for 8 hours, it's going to affect the thing. I have not seen any studies on this. But I don't know. The biggest problem is if you have masks with these exhalation valves. If you breathe in and out, the probability that a dust particle is going to sit on that rubber gasket is very high. Rubber is a sticky material; it will collect dust, and once there is a dust particle on it, it's not going to seal, and then it's not N95 anymore. So I think there's probably a limit to how many hours you can wear it at a stretch.
Right. So final question: how many times can you reuse the N95? So we are talking of extended use here. You leave it away for 96 hours, reuse it. How many times can you do that to an N95?
So again, I mean, for some of these, for time, nobody has really tried because that would take a very long time to do the experiment. If you're doing 5 days and you need to see if it's going to be doing 10 times and you need 50 days for the experiment and people just haven't done it. Most of these quick checks which have been done for either UV or moist heat, people have shown that you can do it 5 times, 10 times. People have shown, but again, the recommendation is check the fit every time. The fit is where it probably is going to go, go bad first. So most people are actually in the field are not using it more than 3 times or so, for no matter what method they use. But I guess even 3M now has a document showing that for some techniques they can reuse it 10 times.
Thank you very much, Arnab. That's been a very, very informative session, and to a bunch of clinicians and biologists, getting to hear about all these fundamentals of physics is taking us back to school. Thank you very much for sharing what you've done and for continuing to work with us.